Hello and welcome back to April May Codes. I'm your host, April May, and today I'm going to work on creating the character for my game and putting them on the screen. We'll work on movement and actions in the next video. So let's jump right into it. For my character, I use the Universal LPC Sprite Sheet character generator. It's an amazing resource. You can customize your sprite however you want, and then download the image as a PNG sprite sheet. So here's what the website looks like. It's got all these options on the left side, different heads. You can do beards and hair. There's a lot of different options, and it gives you the little sprite for each action, facing right, left, moving up, down, right, and left. So my sprite sheet, let me grab that and paste it into my assets. We'll put that in a file called player, or in a directory called player. And I just called this base.py because it's the base.png because it's the base sprite sheet. I've also got one for the axe and pickaxe and shovel and watering images. But this is base.png. I'll zoom out a little bit. So it's got all of the different animations for my sprite. But I needed a way to separate these images, and cropping each one in Photoshop felt like it would take forever. Luckily, Tux Codes has the perfect tutorial for this. I'll link to his video in the description. What he does is create a tile sheet class that creates a tile table of each image and has a getTile function to return a specific image. So I'll go over that briefly now. To start, I'm going to create a support.py file that's going to hold support functions and classes like the tile sheet class. So that's just going to go in game, new file, support.py. Then we'll import Pygame. And then create our class tile sheet. Doesn't inherit from anything. Init will take self, the file name, width, height, rows, and calls. The image is going to equal pygame.image.load, and then the file name, .convertAlpha, self.tiletable is going to be equal to an empty list to start. And then we will do for tile X in range 0 and the columns calls. Line equals an empty list. Self.tiletable.append line. For tile Y in range 0 rows, the rect is equal to tile X times the width, tile Y times the height, then the width and the height. And then we'll do line.append image.subsurface rect.convertAlpha. And we'll do our getTile function. It's going to take self, X, and Y. And that's going to return self.tiletable X and Y. And that's all we need for our tile sheet class. Let's put an extra line up here. There we go. All right, now that I've got that code, I'll explain briefly what I understand of it. But for a more detailed explanation, please check out Tux Codes loading from a sprite sheet tutorial. That'll be linked in the description. Basically, we create a rect that has the tile X times the width and tile Y times the height. So we position it in the top right corner of the tile, then the width and the height, which comes from when we create the tile sheet class. Then we add that line to the rect by taking a subsurface of the image at that rect position. So the tile table is made up of lines of images that we can access with their X and Y coordinates with the getTile function. In order to get anything else on our screen, I've got to first create the game class. So in the game file, I'll go ahead and create game.py. And then I'll go ahead and create a game class that's going to take self and game manager. Let's import Pygame. Self.game_manager is equal to game manager. And then we need a game loop function. For now, this is basically going to be the game manager loop function. Eventually, we're going to add on to this so it will have some extra stuff as well. But for now, all it's going to do is self.game_manager.check_events, self.game_manager.render, self.game_manager.update, and self.game_manager.game_cursor.update. And that's it for our game loop. Then in the game state manager, we need to add to the manager loop. Get game state manager down in the manager loop, which is right here. So we've got while self.running and not self.playing. Now we want to add while self.playing. We'll do self.game.gameLoop. And that's going to give us a little warning because self.game doesn't actually exist yet. But we're going to create self.game before we set self.playing to true. So I think that'll be all right. Now, before we can put our player on the screen, we'll need a state to place them into. In my game, I want the starting state once you click New Game to be the farm. So in states, I'll create a new file, farm.py. We'll import Pygame. And from game.states.state, we will import state. Oops, I had a typo there. There we go. Now we'll create our class farm, which is a state. Init, which will take self, game manager, and a name. We'll do state.init, self, game manager, and a name. And then self.allSprites for now is just going to be pygame.sprite.group. All right, we'll give it a setup method that's going to create the player. So we'll pass for now because we haven't made our player class yet. And then we'll need an update method, or an update function, which will take self, delta time, and actions. Self.gamemanager.screen.fill config.lat. We'll need to import config. Self.allSprites.draw and that needs a surface, so self.gamemanager.screen and self.allsprites.update, and that's going to take delta time. Now let's create our player class. That's going to go in sprites, player.py. We'll import Pygame. From game.support, we're going to import tilesheet, because this is where we're actually going to use that tilesheet class that we made. We'll create a class player, which is going to inherit from pygame.sprite.capital_sprite. Init will take self, a pause for position, a game, and group. And then we'll do super.init, which is going to take the group or groups. Self.game is equal to game. And the pause we aren't using just yet. Now for our image. This is where that tilesheet class in the beginning of the video comes in. So our self.basetiles is going to be equal to tilesheet, and that's going to take the path to the image. So that's assets/player/base.png, the width, and the height, which are going to be 64 and 64. And I'll show you where I'm getting those from in just a moment. 14 for the rows and 13 for the columns. So let's look at the tile sheet really quickly. Each of these squares is 64 by 64. That's where we get the width and the height from. It doesn't want the width and height of your entire PNG. It wants the width and height of each sprite that you want to break apart. So it's 64 by 64. Then for rows, that's horizontally. So how many horizontal rows that I have, and I have 14. And then the columns is how many vertically. So you're not counting for columns up and down, you're counting across how many columns there are. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 columns. So that's where those numbers came from. All right, and then self.image equals self.basetiles.getTile, and then we need an X and a Y. So let's just pick one of these images. This one looks good. So the X position for this one is 0 because it's the first row. And then the Y position is 0, 1, 2, 3. Because it's the fourth one down, so it's the third. With indexing, you start with 0. So 0, 1, 2, 3. So we're going to do 0 and 3 as our coordinates in player.py. All right, there's our self.image. Self.rect is equal to self.image.getRect. And here's where we're going to use pause. Our center is going to be equal to pause. All right, that should be enough to get our player on the screen. Let's go back to farm, and in setup, instead of passing, we're going to do self.player is equal to a player. We need to import that class. It needs a position, so we'll just say 640 by 360. It needs a game, so that's going to be self.gamemanager.game. And a group, self.allsprites. All right, let's import player. And then we need to go back to our title, so that we know when to enter our farm state. So let's go ahead and open title.py. And instead of just printing new game, when enter is pressed on new game, we'll say game is equal to game, which takes game manager, so self.game-manager. And then self.game-manager.game is equal to game. That way game manager has a reference to the game. And then we'll do self.game-manager.farm is equal to capital F farm, which is going to take self.game-manager and the name, which will be farm. Self.game-manager.playing will be equal to true. And you see we gave the game manager a game before we set playing to true. And then we'll do self.game-manager.farm dot enter state. And we'll copy all this and we'll put that for when we click on the button as well. So it's not just when we press enter on it, but when we click on it. We need to import game and we need to import farm. All right. And that should be enough to get our player on the screen. It won't do much yet, but we should see her. Oh, and we don't. Why not? Oh, I know why. It's because back in farm, we defined the function setup, but we never called it self.setup. So when we initiate the farm class, we'll call self.setup, which will create the player. And there we go. There's our player. And if we hit enter, it should do the same thing. Our player's on the screen. All right, that is a start to creating the player class. In the next video, we'll get some movement down and we'll get the actions using the tools down. So stay tuned for the next video, and thanks so much for watching.